Hello, my dear students. Assalamu alaikum. Welcome to you all in today's class. I am covering HSC program Physics first paper, chapter number 2, Factor. In this video, I will discuss about conditions of two vectors to be perpendicular to each other. I have discussed that A dot B equals to 0. If A dot B equals to 0, at that case A and B acts perpendicularly to each other. Okay. Now if I take A equals to 3i plus mj minus 4k and B vector is equals to minus I plus j plus 2k. So I want to make these two vectors perpendicular to each other. So I want to know for which value of m A vector and B vector acts perpendicularly. I want to find out this one, for which value of m A and B acts perpendicularly. So I know that if these two vectors act perpendicularly, at that case A dot B will be equals to 0. So now I take the dot product of these two vectors, that is this component AX into BX, that is minus 1, plus AY, that is M, into BY, that is 1, plus AZ, that is equals to minus 4, and BZ, that is equals to 2, total equals to 0. So what I get? Minus 3 plus M minus 6 equals to 0. That means I get M equals to 9. So I can say for the value of M equals to 9, these two vectors A and B acts perpendicular to each other. Okay, so now you can solve if it is said that that the two vectors act perpendicularly. We'll just take the dot product of them, and if it will be 0, then you can easily say these two vectors are acting perpendicularly. Number 2, if it is said this now these two vectors are not perpendicular, but I want to change any of the components here so that these two vectors act perpendicularly. For example, I want to change the value of m by which these two vectors act perpendicularly. At that case, I will calculate A dot B, and obviously it will be equals to 0. From there, I will get the value of m. Now I can say for the value of m, vector A and vector B will act perpendicularly. Okay. Now I want to draw your attention in another point. Look. Give me a second. Dot product, right? that is A vector dot B vector equals to AB cos theta. Okay, this one is A vector and this one is B vector. A, B. Okay, do you know what is the projection? If you draw a perpendicular line, from B vector on A vector, that means from any vector to another vector, the intersecting part indicates the projection of B on A. So if you denote it by OX, then OX is equals to the projection of B along A vector. Okay, so I want to calculate what is the value of OX. If this angle is theta, take cos theta, that is base divided by hypotenuse. Here base is OX and hypotenuse is the magnitude of B vector. So I get OX equals to B cos theta. OX equals to B cos theta. So this is equals to nothing but B cos theta. Now the important part. Now what we can write? This one is B cos theta. This one is B cos theta. So from this equation, what we can write? From this equation we can write that B cos theta equals to A vector dot B vector divided by magnitude of A vector. Okay, so if you are asked to calculate the projection of B vector on A vector, A vector, you have to calculate the value of B cos theta, and B cos theta is nothing but A dot B divided by magnitude of A. So you will just take the dot product of A and B, you will divide it by the magnitude of A. Similarly, what you can write? The projection of A along B. What we will calculate? Projection of A, that is, we will calculate A cos theta. This will be equals to what? From here, if you want to calculate A cos theta, you can write it this way: A cos theta into B, A dot B equals to. So from this line, what you can write? A dot B divided by magnitude of B. So this one is the projection of A along B, and this is the projection of B along A. Okay, so I have almost covered all the things of dot product of two vectors. In the next class, I will discuss on the cross product of two vectors. Keep watching the next video. Thank you very much.